Hey everyone! Welcome to the channel. Today, I'll be demonstrating how to use ethers.js with Conflux eSpace to deploy and interact with a smart contract. We'll start with a live demo of the application, where we'll log in, check our balance, interact with a deployed smart contract, and send tokens. After the demo, we'll dive deep into the code to understand how everything works. Let's get started. Here's a simple dashboard I've built to demonstrate the functionality. This application is connected to the Conflux eSpace testnet. Users can log in using MetaMask or any compatible wallet, check their balance, interact with the deployed smart contract, and even send CFX to another address. Let me show you how it works. Let me log into the application. Once logged in, you can see my wallet address displayed here. If I check my balance, you can see it shows 942 CFX. This is my current balance on the Conflux eSpace testnet. Now, let's interact with the smart contract deployed on this network. I'll start by reading the current greeting message stored in the contract. As you can see, it's HH. Let's update it to something else, like going great. The application will interact with my wallet to sign the transaction. The transaction is successful. Let's read the value again to confirm. And there it is, great going. The update was successful, and the smart contract is working as expected. Finally, let me show you how to send one test CFX to another address. I'll input the receiver's address and confirm the transaction via the wallet. The transaction is successful. If we check the details, we can see the transaction hash, the amount sent, and the two addresses involved. This proves that our application is capable of transferring tokens on the blockchain. So, this is the working demo of the application. The front-end is fully functional and connected to the Conflux eSpace testnet, showcasing how the smart contract and wallet interactions work. Now, let's move on to the code and see how everything is implemented. Let's break the code into sections to make it easy to understand. We'll cover the smart contract, deployment script, configuration, and how we interact with the blockchain using ethers.js. We created a simple smart contract in Solidity called Greeting. This contract has two main functions: get greeting to read the greeting message and set greeting to update it. It's deployed on the Conflux eSpace testnet. This contract stores a greeting message and allows users to update or retrieve it. The getGreeting function is a view function, meaning it doesn't cost gas to call, while setGreeting modifies the state and requires a transaction. We used Hardhat to deploy the contract. The deployment script compiles the contract, deploys it to the Conflux eSpace testnet, and logs the deployed contract's address. This script uses Hardhat's ethers library to load the contract, deploy it, and wait for the deployment to complete. To ensure the deployment works, we configured Hardhat to connect to the Conflux eSpace testnet. The hardhat.config.js file includes the RPC URL, chain ID, and the private key of the wallet deploying the contract. For front-end interactions, we used ethers.js to connect the application to the blockchain. This connection allows us to perform actions like reading balances, interacting with contracts, and sending transactions. We used ethers.js to interact with the deployed smart contract. One common operation is fetching the balance of an account. Using ethers.js, we can check how much Conflux a particular address holds. Here's how we do it. This code fetches the balance in WAE, the smallest unit of CFX, and converts it to Ether for readability. We can also read data from our deployed contract. For example, to fetch the greeting stored in the contract, we use the getGreeting function. To update the greeting message, we use the setGreeting function. This requires a transaction because it modifies the blockchain state. Finally, let's look at how to send CFX from one address to another. This involves creating and sending a transaction. This code transfers one CFX from the sender to the receiver and logs the transaction hash for tracking. This function interacts with the wallet to sign and broadcast the transaction. And that's it for today. We've seen how to build a smart contract, deploy it on Conflux eSpace, and interact with it using a front-end application. If you found this tutorial helpful, don't forget to like and subscribe. Drop your questions or feedback in the comments below. See you in the next video.